Hello everyone. Today we will discuss sorting techniques. This is again continued from chapter 2 revision 2. Okay. See, first of all we should know that what is sorting. Sorting means arranging elements in a specific order. Arranging elements in a specific order, either in ascending order or in descending order. Okay. Arranging elements in a specific order. Okay. Either in ascending or descending. So suppose we have some list of data. Okay, then one by one we have to arrange these data in ascending or descending order. This is known as sorting. Okay. We oftenly we do in our real life these sorting things. Okay, very much we do. Okay. Similarly, there are so many ways, multiple ways or techniques or algorithms. Algorithm means step by step solution of the problem, means step by step solving or sorting a list of elements is known as algorithms that can be applied to sort a group of elements. Okay, to sort a group of elements we can apply many ways, many techniques, many algorithms are there. Some of them are here. Say these names are like this: selection sort, insertion sort, bubble sort, deep sort, quick sort, okay, and many more are there. Binary sort is there. So many sortings are there, algorithms are there, techniques are there to sort a group of elements. As per our syllabus, CBSE syllabus, we will learn only two ways or two techniques, two algorithms to do the sorting. First we will know bubble sort and then insertion sort. Bubble sort. The basic idea of bubble sort is to compare two adjacent values and exchange them if they are not in proper order. Okay. In bubble sort, what we have to do? We have to compare two adjacent, means side by side elements. Okay. Two close elements, adjacent elements are compared, that which one is greater or which one is smaller, like this we have to compare. If we want to do ascending order sorting, then we have to check that which one is smaller. Okay, and in case of descending order we have to check which one is bigger. Okay, so we have to compare two adjacent values and exchange them, swap them. Okay, swap them if they are not in proper order. Okay, if suppose in ascending order, if we want to compare, we have to compare here that which one is smaller. If the first element is smaller, okay, then it is in proper order, but the second element is smaller, then we have to exchange them. Okay, the smaller will have to take previously before the next one. Okay, then the data, see the examples here. This is the example here given. Okay, we have some elements here. Okay, this 16, 12, 18, 13, 14, 17, total 6 elements, and we want here to arrange these elements in ascending order. See the output here. Output we have arranged, and how it is done. See, first we have to check the first two elements. Okay, these are the adjacent elements 16 and 12. If they are not in proper order, we are here doing ascending order sorting. Okay, so this 12 must be before 16. So here it is not in proper order, we have to exchange these elements. What we have done, we have take this 16 to the second position and 12 to the first position. Now it becomes sorted, it becomes arranged. Okay. Next element we have, we did the same thing with the next element, next two adjacent elements 16 and 18. Now see, these are in proper order because 16 is smaller than 18. These are, then leave it. Okay, don't make any exchange. Then come to next element 18 and 13. Okay, Now what we have to here, now see 13 is smaller than 18. 13 is the next element. Now what we have to do, we have to exchange these elements. Again we have exchanged 18, we have taken to the uh, next to the 13, and then 13 comes to the previous one. But one thing is happened here, that this 13 is also smaller than 16, so we have to arrange it again. Then we have exchange here 13 to the 16 position and 16 to the 13 position, we have exchange here. Now see, up to 18 we have arranged some data. Okay, we have again here checked 13 and 12. Now it is okay. Now next element we have to check here, that is 18 and 14. Okay, here again 14 is smaller. Then we have exchange, and so on we have did the same thing, okay, until the elements is arranged at the proper position. Now lastly we have checked the last element, that it is arranged or not. No, it is not arranged. Then we have arranged here, we have exchanged the data, and this like this the arranged data now comes. 12 is the smallest, then 13, then 14, then 16, then 17, and then 18. Okay, this method is known as bubble sorting. See the program, how we have to write the program, Python program, to sort a list of elements using bubble sorting. Okay, so here we have taken some elements, total of 7 elements in list A named A, and first we have print the original list, how it looks like. Okay, the original list. Then we have taken the length, means total elements n will contain 7, and a loop will be executed up to 7 up to n. And then again next element j is taken up to the range of n minus I minus 1. Okay, n minus I minus 1, from 0 to n minus I minus 1. Okay, and we are checking here that is the element j is greater than the next element, means we are checking here that next element is smaller here, like this. Okay, if it is like this, means if the first element is larger than the next element, adjacent element we have taken here, then we are here exchange the data, means this data j will be replaced with this purchase place, and this element will be replaced with this element, means exchange. Okay, this loop take cares of the rest of the elements and exchange all the elements and do the necessary processing and traversing throughout the whole list of elements, and it makes necessary changes, necessary exchange, necessary swapping of the elements up to the end of the list, so that the whole elements will be arranged. Now after sorting we have again displays the list A. See the output of the program, how it looks like. The output is like this. See, the original list is whatever we have taken, and list after sorting, here each and every element is sorted accordingly. Now come to insertion sort. It is a sorting algorithm that builds a sorted list, one element at a time, from the unsorted list by inserting the element at its correct position in sorted list. Okay, it is similar, it is just the similar way we sort playing cards in our hands. Playing cards, we have in our hands. See here, in this algorithm insertion sort, what there we have divided the list in two parts, sorted part and unsorted part. Okay, one by one, when we take the element and we we find the exact position of the element and put that element that position in the sorted list, in the sorted list. Okay, and from the unsorted list. Okay, from unsorted list we take one element at a time and find the exact position of the element in the sorted list and put it there. Gradually the sorted list becomes bigger. Okay, bigger by one element. Okay, adding each time one element becomes larger, and unsorted part is reducing. Okay, gradually it will reduce, and lastly it will be vanished. Okay, it means that all the elements will be sorted and comes in the sorted list. See the example here. Okay, we have taken one bar, this line. Okay, this line tells that this list is divided in two parts. This list is divided in two parts. First is known as sorted part. This is the sorted part, and this is the unsorted part. Okay, this is unsorted part. And this is the sorted part. What we have to do here, we have to take one element at a time from the unsorted part. Okay, and this element is compared with the sorted part elements, and we have to put this element, this circle element, at the exact position in the sorted part of the list. Okay, if one element is arranged at the appropriate position, then we have to take the another element, then another element, then another element. At last we will find that the unsorted part contains no element. It means all the elements from the unsorted part comes to the sorted part, and elements are arranged, and we have done doing the sorting. Okay. How it is done? How we will find the exact position of the elements from the unsorted to the sorted position? By comparing. Just do it by comparing. Okay. Here we have taken 12 and we have compared with the element in the unsorted sorted part. Okay, then what it will say that 12, if we are sorting in ascending order, then 12 will come before 15. So we have put 12 before 15. Okay, this becomes sorted part. Now 14 we have taken, and we have find here that 14 must be between 12 and 15. 14 is position in the sorted part. Now we have taken 16. 16 position we have find and put it that place, and then 11, then 13, and then each and every element is sorted. Okay, like this it is sorted. One by one we have to take. See the program here. It's a sort program. Okay. Again we have taken one list of elements named A, and so first of all we have displayed the original list, why it looks like the elements are arranged or not arranged. Okay, now we have taken for loop from 1 to length of the list. Okay, see here we have started the for loop from one position, means we have left the first element. We have left the first element and assume that first element is sorted. Here we have assumed that first element is sorted, and rest element we have to sort from the unsorted list. So we started the loop from 1. Okay, now key element we have taken here. Key element means one element, we have to take one element from the unsorted part, and that element will become the key element. Okay, so from AI means AI position I is first one, initially it was 1. So for the element 12 will be the key element. Okay, element 12 will be the key element here. Okay, now what we have done, we have taken j variable, which is the which is the position of the sorted part list. Okay, now we have compared the element with the key element, that it is less than or greater than the element in the sorted part. One by one we are checking here, and accordingly we have put the find the position, exact position where we have to put it here, and then the key is inserted at the appropriate position using this statement. Okay, this statement what it tells, the key element, the element which we have taken from the unsorted part, is searched that where is the position in the sorted part, then that element, this is the position here, and that element is inserted at that position. Okay, first element is completed, then loop will take another element. Okay, loop will take second element, means 13 it will next time we will take, and then accordingly we will arrange the, now 13 will become the key of the key element from the unsorted part, and we have to arrange this key element in the sorted element. So again the for loop will be executed, and this process goes on up to the last element of the list. Okay, after completing the for loop, we again printed displayed the list, that what it does after sorting this thing. See the output here. Okay. See, original list is same as the list, and then list after sorting. Now each and every element is sorted here. Okay, understood? Some assignments related to sorting, how the question will come in the examination. See the questions. These are the questions here. 4 questions only we have given. Okay, you have to do it, and thank you.